Okay, we're going to do binary tree post order traversal. If I'm going to do this a bit quick, but if you want to figure out how to do all these problems, you should watch my video on binary tree post order traversal. Because for in order traversal and post order traversal, I'm writing them quickly with not as many explanations. You can still figure it out by looking at the code, because I'm putting comments. So let's proceed. So we do this in two ways. The first one is recursive approach. And for the recursive approach, we simply need our edge case. I mean, even the iterative. So our edge case is if root is none, then we simply return an empty array. Then we need our result array. Is going to be result is equal to that. And then we create our DFS function, which we're going to call post order. And it takes a node. And what do we do for this node? We simply do if node dot left is none, then post order node dot left. If node dot right is none, then post order node dot right. Right? Because we're doing like this because post order is left, right, root. Right? So here we append val of node to the result. So it will be result.append node.val. And then here we make our function call, which will be post order at root. And then here we return the result. So we return result if node.left is none, has no attribute left. If node.left is, oh, if node.left, not if. This should have been if node.left is not none, right? So node.left is not none. You can write it like that. Node.left, node.right is not none. Sorry, my bad. Voila, that works. So now we're going to do the iterative approach. Using a stack, right? So the way we do this is we create a stack and initialize it with the root and a visited boolean, right? So stack is equal to root and then visited is false. Then we iterate through the stack as long as it's not none. So while stack, then we pop off the node and the visited boolean into a visited variable, right? So node visited is equal to stack.pop. Then we check if the node is not empty. So if node, then we check if it has been visited. If visited, then we simply add the value of the node to the result. So result.append node.val. come on. Else it hasn't been visited, so we add the node and its children along with their visited booleans to the stack in post order, because this is post order we're doing, right? Yes, in post order fashion, right? And since we're adding to a stack, we add in reverse of what's post order? Of post order, which is post order is left right root. So left of left, right root. So what does that mean? This means stack.append. We start with the left, right? Stack.append in brackets node.left. Visited is false, right? Push this down. Stack.append node.right. Visited false. And then stack.append node and then visited true. All right. So this is left, right, root. Because we want the stack to, we want to pop these values off first. So we put them up first. Now we want actually this to be first, right? So we have it at the top. So left, right, root. If it was pre-order, which is root, left, right, this would have been at the bottom here. In order, this comes in the middle here. So it becomes, so left root right actually becomes right root left. All right, so we do that. And voila, that is the solution. Give me 90. Okay, 94. So this takes O of n time and O of n space because we're using a stack, or recursively we're using the stack space in memory recursively. So that is the solution, and thank you. Bye.